Hi guys, welcome back to my system design series. Today we are going to discuss about what is consistent hashing. This is chapter number 6 of DDIA system design series. If you haven't watched the previous video, then kindly make sure you watch it. So today we are going to discuss what are traditional hashing, then what is consistent hashing, then what are virtual nodes, the code or implementation of consistent hashing, real world application, advantages and disadvantages of using consistent hashing. Okay. Why consistent hashing needed? First of all, traditional data partitioning breaks down into dynamic clusters. Before, it was using hash key modulo n. Here, n is number of servers. Keys are keys in request. For example, select all the students who were present on suppose Saturday. So here, select all students present on Saturday. So here Saturday is our key. But why do we need partition? We have already discussed about this in detail in the previous video. If you haven't watched it, I will share the link into the description. You can watch it later. But in short, partition was needed to make the system more scalable. As the data grows, it becomes difficult to write the data or to fetch the data from the database. So that's why partition was useful. Now just imagine there are several servers here. Okay, I will just make sure these are S, and here there is a user. Suppose there are so many users who are requesting to fetch the details, and all the request was bombarding on this particular one server. So this server will become overloaded with the request, so the system will become slow, and all these remaining servers are just sitting idle. So to make sure that all these requests are evenly distributed among all the servers, we are using consistent hashing. But now the main question is what went wrong while using the traditional hashing method. In that, if you add or remove the server, all the keys must be rehashed and moved, which causes mass data reshuffling. This makes scaling and handling data failures costly and very slow. Consistent hashing solves this issue by mapping servers and keys onto a fixed hash space, often visualized as a circle. Suppose this is a circle or a ring. Here there are servers and here there are keys. When a server joins or leaves, only a fraction number of keys needs to be moved. In other words, adding or removing servers only affects the servers who are immediate neighbors on that ring, not the entire system. Consistent hashing was invented to enable elastic scaling of caches and data stores. With minimal redistribution of data, solving the core issue of adding and removing servers in distributed systems. Okay, now let's understand how consistent hashing works. The core idea is to hash both servers and data keys into a one circular hash space, that is starting from 0 to 2 raised to 32 minus 1. This is the total range of unsigned 32 bits. Okay, the main point is when we are saying it is arranged in a circle, that doesn't mean that we are talking about the location or any specific geography area. But circle means the numbers, that are range starting from 0 to 2 raised to 32 minus 1, then again coming back to 0. These numbers are being assigned to the servers. Each server picks a random point on a ring via hash, and each key is also hashed to that point. So a key which is stored at the first point. Here suppose there are servers. These are the keys. These are servers. These are keys. So here the keys are also in form of range. Suppose 1 to 32. Here the range would be 33 to suppose 48, in that ways, and so on. So whenever the request falls under this key will pass on to its immediate server. This passing to the next immediate server will always be into clockwise direction. This way, each server is responsible for the range between it and its previous server on a ring. So this server, suppose this is 11 server and this is the 10th server. So this 11 server will be responsible for all the keys between 11 and 10. And this range you are able to see, this is a human readable form, but usually these are hash keys. And these servers are not 11 and 10. These are also hashed server. That means it would be something like 110 a dollar something like this. Okay, let's understand this by taking an example. Suppose S are the servers and these are the data keys. Now suppose this server and this server, between this one new server is added. Now the keys between this server and this server, all those keys needs to be moved to this node, that is this new server. Similarly, when this server is removed, for example this is removed, then all these keys will be following it to its next server. This is this server. So what this both the scenarios indicate, that only local keys needs to be moved, all the other keys are as it is. So this greatly simplifies rebalancing. So instead of O of n keys, only O of k upon n keys are moved. Here k is total number of keys. Furthermore, to improve the balance, each physical server is often hashed multiple times. Those are called virtual nodes. Without virtual nodes, consistent hashing can lead to imbalance. If you have a few physical nodes and hash each one once, some may end up responsible for large portion of key space. This creates hotspots where one server handles too much traffic, while others remains unutilized. Virtual nodes solve these problems by distributing each server's load more evenly across the ring, smoothing out key distribution, especially when the number of servers are small. It also allows flexible scaling, where the servers with the more resources can be assigned more number of virtual nodes. Let's take an example. Think of hash ring as a pizza and keys as a slice of cheese. If one person, that means one server, gets one slice, that means one position, some person will get thick cheese and some person won't get any cheese. But if each person gets the several small slices scattered around the pizza, cheese is more fairly divided. So when a physical server joins, only the keys between the virtual nodes and its previous server moves, not all the keys. This still keeps the data movement very minimum. Similarly, when a node, that is a server, leaves, only the ranges owned by virtual nodes needs to be reassigned, usually to their next servers. So the load gets automatically and fairly redistributed without affecting most of the ring. Okay, let's understand the consistent hashing by implementing it via Java code. Just understand the logic, language doesn't matter. So we have used the consistent hash ring as a class. Replicas are the virtual nodes as per the actual nodes, that means actual servers. Then we have used sorted map, where keys are our hashes and values are our actual node. Then we have used this constructor to initialize the ring with the nodes and its replica counts. Then save how many virtual nodes the real nodes will get. Then add each node into the ring with its virtual nodes. We are using this add node method to add a node and its virtual replicas to the ring. We are using for loop to create multiple virtual nodes for the better key distribution. Then create a unique ID for virtual node, get the hash for this virtual node, and then insert this thing, the hash and the name, into this ring. Then we are using the remove node method to remove all the nodes and its virtual replicas from the ring. Similarly, we are using the remove node method to remove the nodes and its virtual replica from the ring. Then we are using the get node method to get the node of the given key. If no node exists, then return null. Hash the key to get the position on the ring. Then get all the nodes whose hash is greater than or equals to keys hash in the clockwise direction. If none found, then wrap it around the first key and then return the node at that position. Then we are using the internal method to compute the MD5 hash and convert it to a positive long. Then we are creating MD5 message digest. Then we are generating hash bytes from the input string. Then we are converting the first 8 bytes of hash to a 64-bit long. So this is how the consistent hashing can be implemented. Now you just need to pass the real servers and the consistent hashing will be created. Consistent hashing is a key technique to distribute the data across a dynamic set of servers. Amazon's DynamoDB, Cassandra, Redis Cluster, Memcached uses consistent hashing. Apart from these databases, consistent hashing is used by CDNs, load balancer, and distributed hash tables. And consistent hashing is even a hot topic which is asked in so many interview rounds. Okay, let's move towards the advantages of using consistent hashing. Minimal rehashing. Only the keys which are near to the change node that only moves. Avoiding full remaps. This makes scaling smooth. Second is decentralized. No central directory is needed. Each client can compute mappings independently from the next point is scalable. It makes easy to add many nodes. Each node only takes the portion of the hash space. There is no preferred nodes or bottlenecks. Next is uniform distribution. With good hashing, keys spread evenly. Another advantage is it is simple to implement. As one AWS guide puts it, consistent hashing is conceptually simple and only requires mapping keys and buckets via hashing. Okay, now let's move towards the disadvantages. First is potential imbalance. A name ring with just few points can have uneven segments. So, one must use the virtual nodes per server to smooth our randomness. Second is hotspots. If many keys hash to a small region, one node could become a hotspot. Consistent hashing assumes even hash points. Skew in real keys or node capacity must be handled. Another one is complexity. Compared to simple modular hashing, it is more complex to implement. It needs sorted structures and virtual nodes along with the metadata. So these were some of the disadvantages of consistent hashing. So let's wrap up. We have discussed traditional hashing, consistent hashing, virtual nodes, then we have even saw the code of implementation of consistent hashing, real world application, and then advantages and disadvantages of consistent hashing. So if you are still watching this video, then make sure you like this video, comment your doubts if you have any, and please make sure you subscribe to my channel. It will motivate me to make more videos. Thank you so much for watching.